This is Algebra 2 with trig, 2b.1, Properties of Exponents. First one we're going to talk about is the product of powers. So the main thing that we're focusing on here is that our bases have to be the same. The base is what the exponent is affecting. And as long as they're the same, the property says that we can add two exponents together. Because if you have, let's call it 2 to the third power times 2 to the fifth power, you could write this out as 2 times 2 times 2, and this one would be 2 times 2 times 2 times 2 times 2. That's a total of 8 2's. So that's 2 to the 3 plus 5 is what you're thinking, and that's 2 to the 8th power. The next one we have is the quotient property. With the quotient property, quotient implies that we are dividing. So as long as you're dividing the same exact base, the bases have to be the same, there's a shortcut method that you can subtract exponents. I typically try to figure out which exponent is larger, and I determine how much larger it is to determine how to simplify it. But subtracting exponents is a feasible thing to do. So if we have x to the fifth over x cubed, we could call this x to the 5 minus 3, which is x squared. And as long as it's a positive number, then you know that it's on top of the fraction. The way that I typically do it, I just look to see how much different are these two numbers. This one's 2 numbers larger, so it's going to be x squared on top, which is essentially subtracting, but it's just how you think about it. Power of a power. So we're going to have our base raised to a power, which is raised to a power. This is the power of power property. That's going to be x to the a times b. If we think about it here, we could call it x squared raised to the third power. One way you could do that is call it x squared times x squared times x squared, because it's x squared to the third power. We know that this is 2 plus 2 plus 2, which is x to the 6th. So the shortcut when you have 2 to the third power is just to multiply 2 times 3 to get you to be x to the 6th power. Power of a product. If we have x to the a power, let's just say, let me change that. If we have x times a different base raised to a power. Now notice that this is not a binomial. This is not x plus a value. X plus 2. This is just x times. So it's kind of like 3x or xy. We could, or we would, be able to distribute. I often tell you, you cannot distribute the exponent in. But that's because in those situations you're working with a binomial. This is a monomial. So it's okay to distribute it into multiplication, but you cannot distribute it in if it's a plus or a minus. So our example over here would be 3x squared. You would distribute your square into both of the terms. that would be 3 squared and x squared. We could call that 9x squared. Power of a quotient. A quotient implies that it's going to be division. So here we have bases that are different. An x and a y, they're different. We can't simplify that. So now the best we can do is distribute it in to call it x to the a power and y to the a power. Now notice we can do the same thing but backwards. If you have a fraction that has two different types of bases but has the same exponent, you can bring that exponent to the outside. So what we could call that would be 3 with an x raised to the second power. You can't simplify that, but you could call it 3 squared x squared, which is the same thing as 9x squared. Negative exponents. They're a big part of everything we're doing. Negative exponents, x to the negative a is going to be the same thing as 1 over x to the a. If it's a negative exponent, you put it into the denominator. Now it has a positive exponent. If the negative was already in the denominator, the negative exponent was in the denominator, then it would go to the numerator and become positive. So this would be 2 to the negative 3 is the same thing as 1 over 2 to the third, which is 1 over 8. And then, of course, the zero exponent property is any value, let's call it x, raised to a 0 power. Anytime you raise to a 0 power, it's going to be a value of 1. So even if you have something crazy like x plus 2 raised to the 0 power, that's still going to be a value of 1. So let's use these properties that we're aware of to help us determine how to simplify these. Evaluate or simplify would be what we're doing. We look here, and theoretically, you could say 1 times 1 times 1 times 1 is 1, and 3 squared is 9, so this is 1/9. That's not what we're focusing on at the moment. You can't simplify the 1 and the 3, so we move into distributing in, so we have 1 to the negative 8 and 3 to the negative 2. Because it's a negative exponent, it's going to be written on bottom with a positive exponent. Because it's negative in the denominator, it's now going to be positive when you switch it. Oh, good point. This was already squared, right? So negative 2 times 2 should give us negative 4. And 3 times 3 is 9, and another 3 times 3 is 9, so that's 4 different 3s. That's 81. All right, what are we going to do here with our next one? You've got to make a decision. You decide how to simplify this. We're going to take the w, because they're the same base, we're going to add all the exponents together. This would be negative 3 plus 6 would give you a positive 3. So that's w to the third power. Okay, over here, go ahead, give this a thought of how you're going to do it. Don't just sit there and copy me. So there's nothing that we can do here with the C and the D. Now the D does have a negative exponent. You could bring it on top if that's what you like to do. You could do that now or you could do that later. Your choice. I'm going to distribute in and call that C to the negative 2 over D to the positive 8, because negative 2 times a negative 4 is a positive 8. So the C is going to go to the denominator because it has a negative exponent. It's not happy where it's at. It's kind of like a negative attitude, so it's got to go somewhere else. But the D has a positive exponent, positive attitude. It stays right where it's at. So we don't leave the top empty. We definitely don't put a 0. That would be 1 over C squared D to the 8th. With number 4, you probably wouldn't write this step, but what you're thinking is just working with the A's and just working with the B's. There's no B on bottom, so I really don't have anything to compare it with, but I do have A's on top and on bottom. I can bring my A that's cubed with the negative onto the bottom. So that's A cubed and A to the 5th, which is a total of A to the 8th. And you cannot simplify the 8 and the 2, of course, because they're affecting different exponents, or different bases, sorry. The 2 affects a different base than the 8. Number 5. Here we have parentheses. A lot of people look at this and they think of foiling. But notice that these are monomials, not binomials. So take a moment, try to work through this one, see what you think. We'll work through it together. So one way to organize this is to notice that the 7 would only be working with the numbers. So there is no leading coefficient in terms of a value, so it's just 7 times 1. Then you have a y squared and a y to the negative 4, and you have a z to the 5th, and you have a z to the negative 1. So when you add these two together, 2 plus a negative 4, 2 plus a negative 4 would give you y to the negative 2. 5 and a negative 1 would give you 4. The negative exponent tells you to put the y into the denominator. You never leave your answer with a negative exponent. You always have something to do if it's a negative exponent. Moving over to number 6. Give this one a try. I'd suggest for you to pause the video, work through it, come on back, we'll talk you through it. So here we have a couple different choices. We can either distribute the 3 through to all the exponents. Don't forget that the 2 even has an exponent. What I'm going to do here, I'm going to work with just the A's and just the B's. So you probably wouldn't write it out like this, but the number that's on top would be a 1, so this is 1 over 2. You have an A squared over A cubed, and you have a B to the negative 1 over B squared. That's all being cubed. So what this is showing you is you're only going to focus on the A's and you're only going to focus on the B's. Don't think about this as one giant problem. We have little problems within. So there's nothing we can do with the 1 over 2. I have more A's on bottom, so I'm going to have an A left on bottom. Or you can think about it as 2 minus 3, which is a negative 1. So the A to the negative 1 puts it on bottom. There would be nothing left on top. Here I have a negative exponent, so I'm going to put it into the denominator. That's down there with the square already. So this is going to become 1 over 2ab to the third. Now I've simplified what's inside the parentheses. Now I can distribute in all of my exponents. So this is 1 cubed, 2 cubed, a cubed, and b 3 times 3, which is 9. So that's 1 over 8 a cubed b to the 9. So we'll move over here, getting close to the end. Here we have x to the 4th over x cubed. So how are we going to handle this? You can either distribute first or you can reduce first. Your choice. Have at it. So like the last problem, I'm going to work with just the x's first. I know that I have one x on top, so that gives us x. For my y's, I have a negative 2, so that's going to go to the bottom. That's going to join the 6. It'll be on the bottom, being positive, so now there's 8 on the bottom. 8 y's. So I've worked with the x's, I've worked with the y's. It's still to the third power, so that would be x cubed y 24. Go ahead and try the final one over here. So here I notice that my x's can be reduced and my y's can be simplified. So I have one extra x on bottom and I have a negative y on top, which is going to make this y squared on bottom. My y here is going to go to the top. So one thing we could focus on is this is just one giant fraction. It's not a different type of problem. It's one giant fraction. So I have a 7. I have x cubed on top but x on bottom, so that's going to become x squared. I have y to the 4th on top and y squared on bottom, so that becomes 2 extra y's on top.